Hello and welcome. Pilots are told to avoid thunderstorms, cyclones, typhoons or hurricanes for good reason. Violent downdrafts and updrafts can stress airframes beyond design limits. The thrust of an aircraft's engines may not be enough to get an aircraft to climb out of sinking air. Why then would pilots choose to fly into these storms as we hear they do?
Well, the best way I could describe it is it's sort of like if you can imagine riding a roller coaster through a car wash because you can't see anything out the windows in the eye wall. It's just like a car wash. It actually, even in the middle of the day, gets dark inside the airplane. It's raining so hard. We have the large oscillations and then we have some jarring jolts that hit us kind of out of nowhere, both positive G's and negative G's.
The northern Australian city of Darwin has a reputation for thunderstorm activity during the wet season. Darwinians affectionately call these daily thunderstorms Hector, as in Hector the Convector. In 2006, the US Department of Energy Atmospheric Radiation Measurement Program, the Commonwealth Scientific and Industrial Research Organisation of Australia, National Aeronautics and Space Administration of America, and universities from Australia, the US, Europe, Canada and Japan collaborated in a project near Darwin. The Tropical Warm Pool International Cloud Experiment was to provide the world's most comprehensive set of data about the behaviour of thunderclouds. Weather balloons were released and aircraft used to fly into and around storms to gather data. In the United States, the organisations that fly these missions are the United States Air Force Reserve's 53rd Weather Reconnaissance Squadron and the National Oceanic and Atmospheric Administration's Hurricane Hunters. In the past, before satellites were used to find tropical storms, military aircraft flew routine weather reconnaissance tracks to detect formation of tropical cyclones. While modern satellites have improved the ability of meteorologists to detect cyclones before they form, aircraft are able to measure the interior barometric pressure of a hurricane and provide accurate wind speed information, data needed to accurately predict hurricane development and movement. The term Hurricane Hunters was first applied to its missions in 1946. They flew missions in an area midway through the Atlantic Ocean to the Hawaiian Islands and into typhoons in the Pacific Ocean. The 53rd WRS operate 10 Lockheed WC-130J aircraft which fly directly into hurricanes, typically penetrating the hurricane's eye several times per mission at altitudes between 500 feet and 10,000 feet. They fly 2 Lockheed Orion aircraft and G4 Gulfstream high-altitude jets as well. The idea of aircraft reconnaissance of hurricane storms was put forth by Captain W. Farnsworth of the Galveston Commercial Association in the early 1930s. The 1943 surprise hurricane, which struck Houston, Texas during World War II, marked the first intentional meteorological flight into a hurricane. That summer, British pilots were being trained in instrument flying at Bryan Field. When they saw that the Americans were evacuating their 86 Texan trainers in the face of the storm, they began questioning the construction of the aircraft. Lead instructor Colonel Joe Duckworth took one of the trainers out and flew it straight into the eye of the storm. After he and his navigator returned safely, the station's weather officer, Lieutenant Jones-Burdick, took over the navigator's seat and Duckworth flew into the storm a second time. This flight showed that the hurricane reconnaissance flights were possible and further flights continued occasionally. Whilst satellite tracking is very sophisticated, a satellite can't pinpoint the eye of the storm or measure the barometric pressure there. One of the main instruments used to gather weather data is a sonde.
Hang on to your butts.
All right, here we go. We're about to go through some of the worst turbulence you could possibly go through. We're punching. To collect the data, the mission's loadmaster deploys a series of these cardboard-wrapped capsules called a drop sonde.
This is my station here, the drop sonde station. My primary job is to drop the weather instruments that give us a vertical profile from flight level all the way down to the sea surface of what that storm looks like. This is the actual drop sonde we drop through the launch tube. This picks up wind direction, wind speed, temperature, relative humidity, as well as barometric pressure.
It falls at 2,500 feet per minute, and as it falls several times a second, it samples pressure, temperature, humidity and wind speed. A vertical picture of the atmosphere from the altitude of the aircraft to the surface of the ocean is sent as data back to the airplane. As the air from the sea surface is pulled in towards the eye, it rises and cools, releasing moisture and heat. The heat causes the air to rise even further. That continues building and driving the hurricane. It is also why so much rain comes with a tropical storm. The storm is pushed by trade winds. However, once a hurricane arrives over cold water or land, the energy supply is cut and the storm breaks apart. Winds can be deadly, but 9 out of 10 people who die as a result of hurricanes crossing the coast die by drowning. Thus, if forecasters can see what is happening in the storm as well as the surrounding ocean and atmosphere, they can better predict what the storm will do next. The radar at the front of the jet gives a picture of rain bands and weather ahead. The tail Doppler radar gives a cross-section through the entire storm environment. The list of aircraft that have been lost while flying these missions is long. These include consolidated PB-4Y2 Privateer, Boeing WB-29 and WB-50 Super Fortress, Lockheed P-2V Neptune and Lockheed C-130 Hercules. The evidence for a link between climate change and global storm patterns is clear. Rising global temperatures deliver more energy into the atmosphere, and that manifests as more frequent and stronger storms. Thank you for watching. Do stay safe.